Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about two very important things or concepts, data vault and data mesh. And we are going to look at what is data vault, what is data mesh, in what situations should they be used, what are the pitfalls, what are the advantages. So let's get started. First of all, let's talk about what is the challenge? Why do we need a data mesh or a data vault? So the challenge today is we have huge amount of data. We are in the big data world, and there are three V's that we will quickly talk about so that you understand the context and the challenge of why these kind of concepts of data mesh and data vault are needed. So the first challenge is volume, which means there is a huge influx of data due to a lot of devices that we use today, our mobiles, uh, the amount of data that we actually generate every day, that is leading to this increase in volume. There is also variety aspect where we have data which is structured, unstructured, semi-structured, multi-structured. So data is not just something which is structured and can fit into tables and columns and rows. It has multiple types of data that is getting generated. And the third thing is velocity. The speed at which data is getting generated has increased many folds in the last decade. So, volume, variety, velocity, and the ever going complexity. All these four put together is posing a challenge to ensure that we can scale as per the demand. We can do data quality check, governance, we can have security enforced, and at the same time, the cost needs to be kept in mind, and we want to build systems that are fast, reliable, and insightful. So data is bigger than ever, faster than ever, and more diverse than ever. So extracting value from it without losing control is the real challenge. Maneuvering all the four factors that I spoke about and then deriving insights with security and governance is the real challenge. Now, how do organizations build resilient and scalable data platforms? What do they do? So, organizations have to build resilient, scalable data platforms. So, they have to choose right architectural foundations with the latest and best and greatest modern technologies. Now, some of the things that they today do are they choose cloud native infrastructures. There are multiple providers like Amazon, Google, Azure, which provide large cloud platforms that we can choose from, and we can use the elasticity and the global reach that they provide. It also gives us the flexibility of scaling as per demand, having serverless setups, containerization, so that the load can be dynamically scaled in and out. So, one of the choices that the organizations are making to cater to these complex demands is to choose cloud native infrastructure. The other thing that they are doing is going for distributed and modular architecture. Since the data is huge, a single system may not work or will not work. So that's where the distributed architectures or modular architectures have come into play. The organizations are adopting data lakehouses, data mesh patterns, and all of these for flexibility. They are using distributed storage, they are using distributed compute, whether it is Spark, Databricks, or it is distributed storage like S3, ADLS, HDFS, all of these. But in a nutshell, to cater to big data, distributed storage and distributed computing both are needed. Organizations are also going for pipelines for data ingestion and processing, which are implemented using modern technologies like Kafka, Kinesis, Pulsar, Spark streaming. There are multiple modern technologies. So they can no longer use the old technologies like RDBMS or are set predefined things like how basically how we used to operate 20 years back cannot be used now. The organizations have to move to newer architectural foundations, newer technologies. They have to use ELT instead of ETL pipelines now. The other things that they are looking for is resilience and reliability, because when we talk about big data, one thing which is sure is failure is a norm. It's a distributed, huge architecture, huge cluster of machines. It is going to fail. That's the underlying assumption. And to ensure that these architectures are fault tolerant, there is automatic replication, disaster recovery, and they are highly available. You need multi zone, multi region deployments. And then definitely it increases the complexity of the infrastructure, the complexity of compute. So you need to have monitoring and observability tools. They can be Grafana, Datadog, Prometheus. There are multiple in the market. At the same time, while building these architectures, there has to be a focus on governance and security. And there are a lot of tools that can be used to do cataloging, lineage, metadata management. There are compliances to be followed, like GDPR or HIPAA. So there needs to be proper security control setup. So all of these things are being done by organizations, and this explains how complex the systems have grown. First, we spoke about the three V's and the complexity it introduced, and now we looked at how organizations are catering to these complexities and how complex is this whole architecture. The another factor which is there is scalability for growth. So the platforms have to be designed to scale horizontally. Earlier, the platforms used to scale vertically, which is scaling the memory, the CPU, the storage of a single machine. But now that will not work because data is exponentially growing. So the platforms have to grow horizontally, which is adding more compute, more memory by adding more nodes using elastic storages where it's storage on demand, it is compute on demand, which a cloud provider is giving us. So definitely we have moved from a single machine or a physical cluster on our own premise to cloud where you get storage and compute on demand, and the storage and compute have been decoupled or separated, so you can scale the storage irrespective of the compute. Both can scale parallelly. That's the need of the hour. There is AI and automation that is being adopted. We are automating data quality checks, schema evolution, self discovery, and AI ML is being used rampantly. So there are optimizer based, ML based optimizers for performance, for cost efficiency. So all of these things are being done by organizations to keep up to the data demands. Now, since we have set the premise, now let's talk about data vault and data meshes. First, we'll talk about data vault. What is a data vault? Data vaults are very good for consistency. That's the key here. The blueprint for consistency is data vault. What are the core principles of a data vault? So, first of all, data vault gives us two very important things. One, historical tracking. It stores it's a vault, right? Just like in real world, a vault stores all your precious things. Similarly, here the data vault stores your data and it tracks all the history of whatever changes are happening. It records each and every event or a operation that is happening. So it is traceable up till back to the source, which ensures trust and compliance. When you talk about data vault, it is said that it's a hub satellite link structure. There are three key terms: hub, satellite, link. What is a hub? Hub is nothing but a business key, a customer ID, a primary key in the database world is a unique business key, is a hub. What is satellite? Satellite is all the descriptive attributes along that hub, which gives the full history of the data. And then there is link. Link is nothing but a relationship between the business keys. So to define a data vault, we talk about hubs, satellites, and links. The keys, the descriptive attributes, and the relationships. And the core principle is auditability and historical tracking. What are the use cases where a data vault shines or where it should be used? In regulated industries like banking, healthcare, insurance, they adhere to strict compliance. They need lineage, auditability, and trust. That is where data vaults are widely used. For enterprise data warehousing, where data is coming from diverse changing sources, we need to track the history. That's where we can use data vaults. When we want to do long term analytics, where historical detail and consistency is needed. So, here, consistency and historical detail, the whole lineage is more important than speed. In those kind of use cases, a data vault is really good. What are the benefits that a data vault provides? Like I said, first benefit is consistency. There is a clear separation of keys, relationship attributes, and it also tracks history. So, consistency, scalability, it can easily scale without redesigning the whole model. Integration, it has standardized structure and can support multiple systems. And of course, since there is a audit trail, there is a complete lineage and history, it gives governance, it helps in governance, and it gives a lot of trust and quality assurance. That's where it is ideal fit for regulatory industries. Now coming to data mesh, because these are the two terms where people often get confused, that what is a data mesh versus a data vault. We looked at data vault, which is meant for consistency auditing and history tracking. Now let us look at data mesh, which is about decentralized data ownership. That's the USP of a data mesh. So it's a radical shift from centralized monolithic data platforms which we used to have. The whole concept of a data mesh is domain driven data ownership and decentralization. There is no centralized monolithic approach here. It is meant to handle scalability and challenges of modern enterprise. The main thing here is a distributed ownership and domain driven ownership. What are the key concepts? In a data mesh, we talk about data as a product. Each data domain delivers a high quality, discoverable, and usable data product. There is a domain ownership. We talk about data products, we talk about decentralized ownership. Every domain or data product is has a specific ownership. So if there are multiple business domains like sales, marketing, finance, all of them will have their own data product and they will be accountable for that. There is federated governance, a balance of global standards with local flexibility for domains. So we are designing different domains owned by different groups or data owners, but at the same time, we are talking about a balance of global standards. It's a federated governance. There is tight governance, but it is federated, owned by different data domain teams. So it's a completely decentralized data product ownership. What are the use cases where a data mesh really thrives or can be used? Any place where we have evolving businesses, we cannot rely on a centralized bottleneck. We know that the data products are going to independently evolve because you have different data domains or data products owned by different teams or business units. They can evolve differently, independently. So there is a diverse data consumer team and there are many domains that are existing. So that's where we use a data mesh. What are the benefits of using a data mesh? The data mesh supports three things. Scalability, it can organically grow with your business. Your data products can grow independently. It provides agility, faster innovation because you have separated out the domains and data products and their ownership. So there is no central team, there is no overhead of aligning to that central team. So it is much quicker and agile. There is trust in quality because data is treated as a product and reliability and usability is ensured. So in these cases where you need agility, you need scalability, you have different teams, you have different business domains, you would prefer a data mesh. Now, what are the strengths and weaknesses of data vault and data mesh? If we do a comparison on three aspects, the strength, the weakness, and the philosophy. What is the philosophy of a data vault? It is based on consistency, auditability, and enterprise wide standardization. Whereas a data mesh operates on decentralization, domain autonomy, and agility. What are the strengths of a data vault? It gives you strong compliance, governance, standardized scalable modeling, and an entirely historical tracking and auditing lineage facility. At the same time, data mesh helps in rapid adaptation to business, empowers domain with segregated ownership of different data domains, and it is well suited for diverse evolving data needs. What are the weaknesses? Weakness of a data vault is it is heavy upfront modeling effort. It is slower to adapt to rapid changes, and it can become complex over time because it has a enterprise wide standardization, right? The purpose is to maintain compliance, trust, auditability. Therefore, it is a bit slower to adapt. It is heavy. It is not as agile as a data mesh. Whereas a data mesh, if we talk about the weakness of a data mesh, it requires very strong data culture and maturity for an organization to adapt a data mesh concept where different domains are owned by different teams. It needs a very strong data culture and maturity. There is a risk of data silos if governance is weak because you have different segregated data domains. There is a risk of data silos. Interoperability can become a challenge. So these are some of the pros and cons of where data vault is good or bad versus where data mesh is good or bad. Now, let's also talk about the operational overhead and organizational prerequisite to implement a vault or a mesh. If we want to implement a data vault, then we need a centralized modeling expertise, robust ELT ETL pipelines, and dedicated data engineering teams. Whereas if we talk about data mesh, we require very strong cross functional maturity, domain teams with data engineering capabilities, and very strong federated governance framework because it has different ownership for different domains. So, a federated governance framework, a very strong one, is needed. So, these are the things that we need to keep in mind when we want to build a data vault versus a data mesh. What are the pitfalls and challenges of each of these? So, for data vault, you definitely need a very upfront investment in modeling, and it will be a slower adoption rate as we discussed. There can be a over engineering risk for smaller or rapidly changing organizations because agility aspect is more in a data mesh. So, here that's the risk. For data mesh, we need a discoverability and interoperability across domains because there are multiple domains, and there can be a cultural resistance from teams not ready to own their data because we are asking for specific ownership for each data domain. So that's the risk here. It needs a different mindset in the organization. So we can have either data vaults or data mesh, or we can have a hybrid approach where we use data vaults for enterprise wide integration and governance, and then we layer it with data mesh principles on top of the data vault to create different data products. Definitely, this needs to be a phased phased implementation where we start with the vault, which is the centralized model for stability, and then we gradually decentralize the ownership of the mesh as and when we mature. So a hybrid approach can work, or it can be a data mesh or data vault depending on what we are trying to achieve. And then final concluding thoughts on this. There is no one size fit all solution. You cannot probably segregate something to be just a data vault kind of a use case or a data mesh. So you have to choose a right architecture based on your need, your business drive, your organization's readiness and culture. That is also very important. So we have to stay flexible, adopt and evolve as per situation, and we have to encourage the teams to keep learning, experimenting, and refining their data architecture journey. They have to experiment with a hybrid approach too to see what works best for them. So that's all about data vault and data mesh. Hope this video has helped you, and please like, share, and subscribe to the channel for more interesting videos. Thank you so much.